Cisco Certified Network Associate Day 10. Welcome back everybody, I'm Imran Rafa, your trainer for this entire series. Today we would be dealing with the switch port modes and different functions of a switch. So without wasting much time, let's get straight into today's class. Right, like I said, the overview of today's class, we would look at the switch port modes and we will look at switch functions. The switch has two modes. The first mode is the access mode. An access mode is used when you are connecting a switch port to an end device. So let's say if you want to connect your computer or your desktop to a switch, that particular port we configure as an access port, right? The configuration or the command for configuring a port, switch port in access mode is switch port mode access. And by this level in our training videos, you should be able to identify that when the command, the switch port prompt, when the switch CLI prompt says config-if, this should tell you that this is a command that is being typed in an interface subcommand, right? So that is, I have used interface fa0/1 or fa0/something, and that is why the prompt has changed to -if, right? So this is a command in the subcommand under interface on a switch. So you go into any interface, whichever interface that you want to convert to an access port, you go there and say switch port mode access. Typically when you type a command like switch port mode access, there is another VLAN command that we need to give, but at the moment don't worry about VLAN. At the moment only worry about the mode. So like I said, the first mode we're talking about is the access mode, and like I have mentioned here, this mode is used if you are connecting that particular port to an end device, right, like your computer or your desktop. The other mode a switch port can take is known as the trunk port, right? So what's a trunk port? A trunk port is a port that is connecting two switches. So if you're connecting a port of a switch to another switch, right? If you're connecting to another port, so basically a switch is connected to a switch, that particular port through which you're connecting a switch to another switch should always be a trunk, right? So trunk, the word trunk is a very Cisco word. Normally all the other manufacturers call it a tagged port, but Cisco calls it a trunk port. So typically both the trunk port or the tag port, both of them have same function. What they do is they make sure that they carry all the traffic that is there in a switch, right? So basically they share. So at the moment we don't know, we haven't spoken much about VLANs, but when we talk about VLAN, we will come back more into trunk and we'll talk different aspects. But at the moment, you know that trunk mode is used when a switch is connected to another switch. Access mode is used when that switch is connected to a end device. Right here, when I say switch, what I literally mean is that particular port. So these modes are not for the switch. These modes are for the port, the particular port that we're talking about, right? So these are the two modes each switch port can be in. And just like how we discussed the command for putting a port in access mode, the command to put a port in the trunk mode is switch port mode trunk, right? So when we talk about switch port modes, there is another protocol we need to talk about, and that is the dynamic trunking protocol. Now this protocol is a Cisco proprietary protocol. That means to say that you cannot use this protocol with any other switch, right? Any other switch manufactured by any other manufacturer. So only if you're using a Cisco switch, you would be able to use this concept or this protocol called DTP. Of course, I know there are some manufacturers, because Cisco is such a huge company and such a well accepted company in the industry, there are some manufacturers who makes use of the DTP concept of Cisco, right? But since this video series is about Cisco and CCNA, we are going to stick to Cisco, right? So in DTP there are three modes, or rather there are two modes: dynamic desirable mode and dynamic auto. And the third thing that you see here on screen is no negotiate. That is a way to disable DTP. So let's start from the top. when a switch port is in the dynamic desirable mode, what it does is it immediately starts sending out DTP packets, and that means it starts sending DTP packet to negotiate. And what is it negotiating? It's negotiating a trunk. So you should get the hint from the protocol name. It's a dynamic trunking protocol. That means what does it negotiate? It negotiates a trunk. So the minute another device is connected to that port, and if that port is in dynamic desirable mode, what is it desiring? It is desiring to become a trunk. So it's going to tell the other port, okay, I would like to become a trunk. What do you want to become, right? And if the other side also is in dynamic desirable, boom, immediately both of them become trunk ports, right? But let's assume one side is in dynamic auto, the next command here. So one side is in dynamic auto, the other side is in dynamic desirable. Again, the dynamic desirable switch will send a DTP packet to the dynamic auto switch, and the dynamic auto switch will say, fine, I'm configured for auto. That means I can do whatever you want. So you want to become trunk? Fine, let's become trunk. But if there is a case where both these switches are in dynamic auto, then that's a problem. Both of them auto will do nothing, because dynamic auto is a very flexible state. It just waits for DTP negotiation. It will never initiate a dynamic trunking negotiation. So if you keep both the side as the dynamic auto, then it will not work, right? So if you want to create trunking automatically, then you need to make one side at least, or both sides if you want, as dynamic desirable. Now you might say, okay, this is good, you can create automatic trunking, right? You can create automatic trunking. So if you connect another switch, automatically that negotiates a trunk and the trunk is formed. But come to think of it, keeping your switch port in dynamic auto or dynamic desirable is not very desirable. Why? Because let's assume in our organization we have kept all our switches in dynamic auto or dynamic desirable. Now if there is somebody who wants to hack into our switch, or let's assume one of our employees turns out to be a bad guy and he wants to hack into the system, it's very easy. All he has to do is get another switch, configure that port, whichever port is connecting to our office switch, with dynamic desirable. So immediately it will start negotiating trunk with this, and if it negotiates a trunk, and if this is in dynamic desirable or dynamic auto, they will actually form a trunk. The problem with forming a trunk with a switch is that it will send all the traffic, a copy of all the traffic, to that switch, because it's a switch, right? So this is how trunks work. If two switches are in trunk, or three switches are in trunk, they will share the same data. It is like extending your switch. If your switch has got 8 ports, you connect another 8 port switch and create a trunk between them. It is as if that entire switch is a 16 port switch. That's how it is basically by default. I'm obviously there are ways of pruning traffic, making sure that traffic does not go from one switch to the other, but on a general case, by default, if you connect two switches and form a trunk between them, it is as if those two 8-port switches have become one large 16-port switch, right? So if a hacker gets access to our switch and creates a trunk with his hacking switch, then your company switch is actually sending out all the traffic to his switch, and he can create, like we discussed in our last video, he can use any packet analysis software and literally analyze the entire traffic of our organization. So the ideal situation would be to switch off, or rather non-negotiate, by using this third command there, which says switch port no negotiate. So use that command and disable DTP if you're not using it, right? So that's how you disable it. So when you create switch port mode access, that disables trunking. That's, you're statically configuring the modes like we discussed in the last slide. So you can statically configure whether you want mode access or mode trunk, but if you want dynamic, then we make use of DTP, right? So that's the concepts, and I'm sure I hope you have understood so far, right? Next, let's go into the switching functions. Basically, switch has 3 functions, or we're going to discuss 3 functions today, and that's the address learning function of the switch, forwarding decisions of the switch, and loop avoidances. So let's start with address learning. How does a switch learn addresses? Now, we have discussed this many times in our previous videos, but let me, because we're talking about switching here, let me talk about how switches learn address once again. Now, like I told you in one of my old video, when a switch comes on, within 30 to 40 seconds, all the devices connected to that switch literally starts chatting. Now that's what computers are for. Computers love chatting. Computers send broadcasts every time. They keep sending, they keep talking, right? So it says, hey, this is my MAC address, and they keep sending broadcasts. So let's say there are 5 devices. When the first device sends, my source address is this, he sends broadcasts, different broadcasts. Might be ARP broadcast, it might be your different services that's running on your operating system. Those try to communicate with the network, and every time that device communicates with the switch, it has to send its source MAC address. So if the switch gets, let's say, from the first device that's connected to port 1, if it gets a broadcast message, it reads the source MAC address of that device, and it says, okay, my port 1 is connected to this MAC address, right? So it creates an entry in its MAC address table, or the CAM table, right? At the same time, maybe second device, third device, fourth device, fifth device, all these devices start sending broadcasts, and every time it sends a broadcast, it immediately picks the source MAC address and creates an entry in the MAC table. Now, if one of those devices wants to communicate with another MAC address, it sends a packet, and the switch looks at the destination MAC address, and it looks at the CAM table. It knows that that particular MAC address is sitting on one of those ports, so it can immediately make a switching decision. So that's how the address learning process is. Now, we spoke about forwarding decisions, so let's look at it a little more. There are 2 types of switching forwarding decisions that a layer 2 switch makes. It can use the cut-through switching, or it can use store and forward switching. Now, what's the difference between these? Let's assume one device wants to communicate with another device. So what it says, okay, this is my destination MAC address, this is my source MAC address, and all the other information that follows, right? In cut-through switching, when the switch receives a frame, it immediately looks at the destination MAC address. So it just waits for the first few bytes of information, by which time it has all the information it needs, that is the destination MAC address, and it immediately starts sending that frame out on that interface. So it doesn't wait to receive the entire frame. As soon as it receives the destination MAC address detail, it starts forwarding whatever information it gets to that destination port, right? That is how cut through works. Now let's look at store and forward. What store and forward does is, the switch waits until it receives the entire frame. So it gets the entire frame, it runs through error detection, it checks if there are any errors that were induced during transmission. If nothing, it will start forwarding out the destination port. Now, some people might say, okay, cut through is good, and some might say, no, we need error detection, so store and forward is good. But like I said, there's no right answer. Either of them can be right depending on your situation. Do you want faster services? Do you want the switch to work faster? Then you would go with cut through. Do you want more reliable switching? Then maybe you would go with store and forward, right? But these are the 2 different switching methods the switch layer 2 switches implement. Next, we'll look at loop avoidance. Now, what is loop avoidance? If you remember from my old video, I said that when a switch receives broadcast, what it does is it takes that and it sends out in all the ports. So let me take a pen. Let me try to show it in writing. Okay, so this is a switch, okay, and this is a switch, right? I don't have my pen today, so I'll have to make use of mouse. This is a switch, so when you see 2 arrows like this drawn on any logical diagram, you need to know that's a switch, right? So that's a switch. Let me change the color. Right, so normally you would connect one switch to another switch, and this becomes what? Yes, it's a trunk. You're good, you're learning very fast. Okay, so you connect 2 switches, using a trunk. So now this is your trunk. But as your network grows, you wouldn't want to just have one wire. You might say, okay, we might have a disconnection sometimes. So instead of doing the whole wiring, maybe these two switches are in two different flows. So instead of keeping one wire and just waiting for that to disconnect or get cut or go faulty, and it's a big headache to rewire, especially if it's in two different flows. So what you normally do is you would keep two wires or three wires, some backup wires, right? So this is like a backup wire. So again, because it's connecting two switches, it's a trunk port. So you would say, of course, we can disconnect this and keep unless this goes faulty, and then when it goes faulty, you can connect these. Of course, you can do that, no problem. But ideally, I'm sure almost all network administrators would want the wires connected. They don't want to have that headache of tracing those cables and plugging it again. So we would connect these two cables. So the problem is when you connect these two cables, and if you connect two devices, switches with two cables, what happens is, if there is, let's say there's one device here, right? This is computer, and if this computer sends a broadcast, right? It sends a broadcast. Now what does a broadcast do? According to what we know, when the switch receives a broadcast, it will send that traffic out on all the switch ports. That means it will send that traffic here, and it will send that traffic here, right? So it'll go here, it'll go here. Now when this device gets this broadcast, it will take that and it will send it out on this port, right? It's a broadcast. That switch doesn't know that that broadcast is coming from the same switch, right? But for that switch, it is another port, so it's going to send it out here. And the traffic coming from this port, the switch is going to take that and says, okay, you need to go out on this port, right? The same thing happens here. It comes all the way here. This switch is going to think, okay, that's another broadcast, I'm going to take it, put it on this port, and whatever traffic, this traffic coming through this port, this switch is going to take and put it back here, and this process will continue. It'll go around and round and round and round and round, and this process is known as the layer 2 loop. Now it's very difficult to identify a loop. If at all you have a loop in your system, it's very difficult to identify, because you wouldn't know. There is no indication saying there is a loop. I mean, the switch wouldn't even know that there is a loop happening, right? Unlike layer 3 traffic, when we reach layer 3, we'll see that layer 3 has many loop prevention mechanism, but a layer 2 traffic does not have any loop prevention, like time to live, right? So we don't have that concept of time to live for loop layer 2 packets. So how to solve this problem, right? One intelligent lady wrote this protocol known as spanning tree protocol. You could learn a little bit more about spanning tree protocol if you want by doing a Wikipedia search, but just to understand the concept of spanning tree. And like I said, we will come back to spanning tree a little later in the series, but at the moment I just want to introduce you all to this concept. So what is spanning tree protocol? Spanning tree protocol is a protocol that identifies if there are redundant links. So if it sees that, okay, there are two links connecting to the same switch, right? These two switch, same switch, and two links connecting to that, it knows that a loop will be formed. So immediately it does what it has to do. We will discuss that in a later part of this video when we discuss spanning tree in depth, right? I promise you we will come back to it. But for now, it has its own protocol. It uses its own rules. It disconnects, or logically, I mean physically it's still connected, but logically it disconnects one side of that of the second cable. So one pair of port is going to work perfectly, so that's going to be the active link, and then you will have a backup link with one of those ports logically shut, right? So it'll be shut. Now what happens if for some unforeseen reason this cable gets disconnected, right? Immediately STP will know that this link has stopped working. It will enable this port, and this port will start working, and this will become the active link. This is spanning tree protocol for you in very short form. So basically, to summarize, spanning tree protocol is a mechanism to disconnect a backup line. So that's how this tree is. I mean, I think about spanning tree protocol like that. It's just like a tree falling on the road and this road is disconnected, right? So this is spanning tree. We will come back. A lot of topics that we discuss in the early stage of CCNA, we will come back later with much more in depth. So this is what I keep telling my students: don't worry if you don't understand too many things, because it's like building the structure. If you're building a tall building, you don't start building from ground up. You don't paint the walls on the ground floors and then start building. You just build the frame, the structure first, from, let's say, floor 0, from your ground floor till maybe, if it's a 50-story building, you build the frame for 50 stories and then you start putting the walls for that building, right? So most of the things we would be just brushing through now, right? So once we do the brush up, we will come back and construct the walls, right? So at the end of the series, maybe 40 videos or 45 videos or 50 videos, I don't know. I'm just doing, when I think there is a good topic that I need to add, I'll keep adding. So when we finish this entire series, trust me, you will have all the knowledge for your CCNA, and trust me, you will have much more knowledge than what is required for your CCNA. So that's my promise. All you have to do is stick around and you will learn, right? So I think that's all that we wanted to discuss in today's video. Thank you so much for watching. Don't forget to like our Facebook page, and don't forget to subscribe to our YouTube page. And if you want, like I said, you know, if you go out to our Facebook page, you will see that we need more likes. We need people to share our videos. We need people to like our page, invite your friends. And I'm going to set milestones now. If you go to our Facebook page, you will see I am setting milestones. So if you help us reach a certain number of likes, we will put the next video, and you will see the milestones there. So it becomes very easy. If you want the next video, quickly go invite your friends, share that, get the likes up, and automatically new videos will come. So 50 videos can take 50 years I don't know, or maybe it can take 5 months, or maybe it can take 5 weeks. It all depends on how you guys support us, how you guys subscribe to our channel, and how you guys share our Facebook page. So start liking, start sharing, and share the love. Thank you so much for all the love and affection. Bye bye.